Okay. So I'm Stephen Englehardt, and I'm going to be talking about assessing privacy in web standards, and specifically looking at it through the battery status API, which I think has had a really interesting development. Right? It was introduced into browsers. People found a bunch of vulnerabilities, and it was eventually ripped out of a couple browsers. And so I think that's kind of unusual, and we want to look at what happened and what led to it. And so I'm sure I don't really need to convince anyone here that new web features lead to privacy concerns, right? But I think the one example I like to give of how things might be changing is virtual reality, and specifically web VR. And so you can have virtual reality in the browser, right? You can go to a page. They can drop you into this VR session. But part of doing VR is configuring the headset, and part of configuring a headset is knowing some parameters about the user's eyes, and specifically the interpupillary distance. And so the initial version of this spec exposed this IPD to sites if you were in this VR mode. And so my point being, if I was a tracker, having the distance between the pupils of the person who's looking at the page right now might be pretty useful to track them across sites. And I don't mean to pick on this spec. I think they've actually done a good job of looking at privacy and security issues. But my point is that things are changing, and maybe we should see how we address, take a look at how we address privacy and standards. And so the W3C has a couple things in place to help with this. The first is this self-review questionnaire. And so this basically says to spec authors, hey, think about different threat models. Ask yourself a bunch of questions here. And examples are like, do you have any PII? Do you have high-value data? Are you creating any new state on the browser that's not cleared when the user clears their cookies? Something that could allow tracking after the user clears cookies. And then has a couple different suggestions. And this one I thought was interesting. It says, drop the feature 4.3. So maybe just don't implement it after you're done with this. I don't know how often people will take that recommendation. But it's definitely a great document. And then there's also the Privacy Interest Group. And I've given their statement here, but I think point 3 is really important. And it's basically they provide guidance and advice for spec authors. And so the idea here is you can either go to them with your privacy assessment or security assessment already completed and say, hey, does this look appropriate to you? Or you can actually, I think, ask them for advice or help in doing the assessment. And so let's look at the battery status API. It's pretty simple. It basically gives you the charge level of the device. So any script in JavaScript could say, hey, what's the current charge level? Is the battery or is the device currently charging? And how long will it take to discharge or charge, depending on if it's charging? And in the paper, we go through this big series of events, right? And I won't have time to talk about all of the important events during the talk today. So I encourage you to check the paper out. It's available on any of our websites. But instead, I'll focus on kind of the high-level, I think, more important points in the development. And the first is that when the spec advanced to the candidate recommendation level, it added in this privacy and security section here. It was the first version to add that. But it basically said the information disclosed by the API has a minimal impact on fingerprinting or privacy, and therefore, we don't put any limits on how it's exposed. And so I think this is important because the spec authors clearly found something that they felt had a privacy impact. But instead of enumerating what that was, they just kind of said it was minimal, and so we don't recommend any protection measures. And then after that candidate recommendation, during that time, it was implemented in Firefox. It was implemented in Safari, but I don't think it actually ever shipped, and eventually implemented in Chrome. And then later on, some new research exposed a couple of vulnerabilities. The first was this leaking battery paper by Lukács. And it found kind of two main points that are relevant here. The first is that the battery status API could be used as kind of a short-term identifier. And the example I like to give here is, like, let's say you have a bunch of MacBook Pros behind a NAT. Their fingerprint may be pretty similar because the hardware itself is pretty similar. But you could use the battery status of each of them if they were in various charging states to differentiate. And the second example is Firefox on Linux was actually returning high precision values, and that could allow an attacker to recover the battery capacity of that device. And I won't have time to go into the details on that, but you can check out this paper. And the second paper was a measurement paper done by myself and Arvin, and we found basically that not only is this a theoretical attack, but we see fingerprinting scripts in the wild collecting the battery status while they're collecting a bunch of other fingerprinting vectors. So they're definitely using it as part of something to identify devices and users. And the spec was updated to address these vulnerabilities. Specifically, they said, you should avoid these high-precision readouts that would prevent this long-term battery capacity recovery. And you should inform the user when and who's using the API. And this I actually haven't seen in any of the browsers, so I don't, it's a recommendation, but I'm not seeing it implemented. And then maybe ask for permission, maybe obfuscate or expose fake values if you'd like to. And then in late 2016, this kind of came as a surprise to us. Having done these measurement papers, we thought maybe the spec would change, but we didn't think this would happen. Mozilla actually proposed to remove the API. So they sent out a post on dev platform, their mailing list, and said, basically, can anyone point to a real website using the battery API for some legitimate purpose that we want to support? And after some back and forth, kind of one of the last posts in the thread said, OK, so everyone agrees there are some theoretical good things that can be done, but we just don't observe them. And then early 2017, they ended up restricting it to non-web content. So the browser could obviously still use the API, but no one could on the web. Safari ended up pulling it out of the tree. Like I said, I don't think it actually ever shipped, but they removed it. So therefore, it's kind of an indication they have no intention to ship it in the future. In Chrome, it's still unknown. There's an open bug. There's been some discussion, but it's not clear where that's going to go. And then we just wanted to point out Yandex browser. Maybe it doesn't have as large of a market share as the others, but they ended up switching this to an opt-in only model. So the user would have to go and enable the API if they actually want to be able to use it. And I think that decision was made kind of on very little information. The dev platform mailing list, basically, there were, I don't know, 5 or 6 responders who gave some anecdotal examples of where they've seen the API in use. But we wanted to go and do a full measurement. So we looked at the top 50,000 sites to see, does this reflect kind of what Mozilla was thinking in the dev platform mailing list? And it basically does. We found 33 third parties using it, about half of them for tracking. 8 were using it for these kind of benign purposes, basically performance measurement. And I don't think that's really the model, or that's really what the spec authors were thinking about when they implemented the API. They didn't just want to make it easier to do some performance measurements. And 9 of them we had a little trouble classifying because they were very simple scripts. It wasn't clear what their purpose was. And so how can we improve the privacy review process? And this is the section of the talk where me, as someone who's never participated in the specification process, is going to give advice on how to do privacy reviews in the specification process. And actually, Lukasz is the kind of expert here, but I think this has been my first time moving into it, and I'd love to hear your thoughts on our ideas and maybe pointing out why the things we think can work or can't work, and so on. And so first, I think the specification process should include a privacy review of the implementations. And so a spec, to move through the various levels, needs 2 interoperable implementations. And so to me, it's why not also require a privacy review of those implementations? So not only have a section in your paper, but review what the various browser vendors have done. And I think that would have helped catch this double precision issues that cause this long-term tracking identifier to be possible for the battery API. And actually, Lukasz participated in a review of the ambient light sensor API in which they did basically find the same vulnerabilities. They found that it was returning these high double precision values. And the second recommendation is that you should audit, and this is coming from me, I think perhaps as a measurement researcher, but audit the use of APIs after implementation. And I think the point I want to stress is that trackers will be the early adopters of basically any new API. At least this is what I've seen doing fingerprinting measurements over and over. And so I think you'll have people that are, you'll have sites that are using it as intended, right? You'll have some cool demo that comes out after you release the API. You'll have a couple sites being early adopters. But then for the unintended case, you'll have some tracker implemented, right? And that tracker happens to be present on hundreds of sites. And now the majority of your brand new API use is for tracking, which is probably not what you hoped. But I think it provides an opportunity, right? If you do this auditing right after or shortly after releasing the API, you can probably correct some of the vulnerabilities in the API before it becomes adopted by things that you don't want to break, right? The intended uses. So you're less constrained early on to make these changes. And the next is that we're not sure that the measurement community will continue to support the same kind of level of fingerprinting studies that they have. And the concerns are basically the lack of novelty in measurement techniques for new techniques, right? Because that's part of the reason we're able to publish these results. That the measurement of each new API is kind of a smaller contribution. And so it's, if some new API comes out and I want to do a measurement study on it, it's going to be a little difficult to publish that. And maybe the specs can't wait for the publication cycle. And so the suggestions are, to do measurement through telemetry probes. And I know that that exists right now, and it's typically whether or not an API is being used. But I think actually it would be important to have things like which properties are being accessed, which methods are being accessed for the API. And if we could figure out a way to do it privately, even kind of the arguments or the return values for those properties. And that's really what we need to use when we do this kind of fingerprinting measurement. And then maybe we could move measurement to browser vendors, or perhaps something like an NGO or archive.org, right, where you could still do crawls, not have it be based on users, but have some kind of regular measurement happening. And lastly, I think specification authors should do assessments with multiple threat models. And this might sound, again, like kind of a simple recommendation, but I think it's helpful to go through an example here looking at the audio API. And so we measured this. We discovered this being used for fingerprinting last year. And we wanted to see, OK, how identifying is this? Like, what is this providing you in terms of identifying or differentiating users? So we collected a bunch of data for real users, and we found it's essentially the user's operating system and their browser, right? It's kind of correlated to those two pieces of information. And so for the average device, it's like, OK, you can get that through the user agent string, so it's no big deal. But I think it would be useful for something like the Tor browser to know that this will reveal the user's OS or the user's browser, and Tor browser in particular wants Windows, Mac, Linux to all kind of appear or have the same fingerprint. And so we had a bunch of other recommendations in the paper. I didn't have time to go over all of them today, but looking forward to the discussion to hear your thoughts.